All right, we are now recording. Let's get the slideshow set up for the current slide. So we won't be using this until we finish the vocabulary in 2.2. All right, any questions before we get started? Let me make this one last, in fact, it's going to be a couple of announcements here, and they do pertain to this class. The first one's generic. Normally I'll have office hours on Friday morning on the Birmingham campus, 7:45 to 11:45, not this Friday. Okay, I had my first round of the new treatment Friday. The reduced dosage, everything went well. I broke out once, and they gave me more Benadryl. It went away, but it took about 7 hours. Okay, so this Friday I have the full treatment. 1,000 milligrams, and starts at 7:30. I got to be there at 6:30 for blood work, and I'll be there at least 7 hours. So, will not be on campus Friday at all. Okay? And here's sort of the bad news, and I can't tell you specifically yet. I've got to find out the specific time, but I do have a doctor's appointment. My hematologist only sees patients on Tuesday mornings. So, next Tuesday morning, I do have an appointment. That's 1 week from today. It's election day. I believe it's an early morning appointment, so therefore I won't be meeting this class, but I'm going to find that out for sure. Now, what we need to talk about is how do you want to make it up? When do you want to make it up? I hate for you to lose a class, and I'll record it on Screencast-O-Matic, so even if you can't be here, but I'd like to do it at a time when as many people as possible could do it. We could do it, say, this afternoon, 12:15 to 2 o'clock, anytime in there, Thursday or Tuesday. Any one of those would work for me. Or tomorrow afternoon after 2. I could do it then. Or Monday or Wednesday of next week after 2. Is there some time that some of you would like to do it? If I'm going to do a makeup class, when would suit you best? Tuesday, Thursday, 12:30 to 2, or sometime in that time frame, or Monday, Wednesday, anytime after 2. Does anyone have a preference? Could you make any of those? Okay. Could anyone make any of those that would choose to? What's that? Yeah, okay. So nobody has any time they could do it? Tuesday, Thursday, what time would be better? After 12? Okay. Well, 12:30-ish? Is that okay? Okay, well, that's all right. I mean, okay. Do you want it today, Thursday, or next Tuesday? Doesn't matter to me.
I'm good for Tuesday and Thursday after 12.
Okay. Which day would be better for you? Today, Thursday, or Tuesday? Let's rule out next Tuesday because I don't know exactly what time I'll be through, so it may not be good. Today or Thursday? Want to do it Thursday? Because I think the math team may be meeting today. So Thursday at 12:30? All right, we'll go Thursday at 12:30. And 12:30 to 1:45, and then we'll go from there. Say again? Say that again. I can't hear you. No. There's no points involved. It's just whether you get the material. I'll put it all on Screencast-O-Matic, so any of you can pick it up afterwards. But just being here, you can ask questions when it's happening. Okay? That's the only disadvantage of not being here, is you can't ask questions on Screencast-O-Matic. Okay, so Thursday, day after tomorrow, 12:30, we'll make up the class for the following Tuesday. Now, by then I will find out what time the appointment is. I believe it's like 8:30, 8:40, something like that, so I wouldn't be able to be here anyway because I have to be there an hour early for blood work. So, but if I find out it's 11:40, then I may be able to make the class and we won't have to do it on Thursday. So I'll let you know, Thursday for sure. All right, any other questions? And then also, that also affects other office hours because I've got to make up my other 2 morning classes on Tuesday and Thursday, next Tuesday. So I'll be sometime this week or next week doing my linear algebra class and my differential equations class, making those up as well. Those will be a little easier. They're smaller classes, so it won't be as hard to find the time, I don't think. Okay, we're on page 133. If there are no questions, these are the vocabulary questions for section 2.2. The graphs of all polynomial functions are blank, which means the graphs have no breaks, no holes, no gaps. The graphs of all polynomial functions are blank, which means the graphs have no breaks, no holes, no gaps. They're what? Continuous, exactly. Okay? Number 2, the blank, blank, blank is used to determine the left hand and the right hand behavior of a graph of a polynomial function. No, that determines whether it's a function. Huh? That determines if it's a one-to-one function. The what? Okay, the leading coefficient test, or leading term test is what I like to call it. Leading term test, or leading coefficient test. Number 3, a polynomial, I can't talk. A polynomial function of degree n has at most how many real zeros? Its degree n has at most how many real zeros and at most how many turning points? Okay, I have more than one. N. The key here is a polynomial of degree n has how many, at most how many zeros, real zeros? N. If it has degree n, it could have up to n real zeros. Like I was saying, n. How many turning points at most? N minus 1. Very good. All right, that was the trick. Okay, no one. All right. Number 4. This has 3 parts. When a is equal to 0, no, I'm sorry. When I can't read. When x is equal to a is a 0 of a polynomial function, the following 3 statements are also true. When x equal a is a 0 of a polynomial function f, the following 3 statements are also true. A, x equal a is a blank of the polynomial equation f of x equals 0. Equals 0. A 0! All right, it is a 0 of the function equation. If that's the 0 of the polynomial function, it is a solution or a 0 of the polynomial equation. Okay? A root, that's another word you can put there. Number B. Blank is a factor of the polynomial f of x. When x equal a is a 0 of the polynomial function f, then blank is a factor of the polynomial f of x. How do factors look? Okay? And what goes in the parentheses? That's the key. Huh? Okay, guess time is over. Okay. When you do, I can't. What's the F word? A factor of the polynomial. All right. What is the factor? No, that was in the question. What is the factor? How do the factors look? Okay. When you factor the polynomial, how does that look? What goes in those parentheses? Typically. X minus A. That would be the factor. If x equal A is the solution, or the root, or the 0, x minus a is the factor. Number C, the parentheses, a comma 0, okay, is, that's a point, a comma 0, is an blank of the graph of f. X-intercept, exactly. Number 5, when a real zero of a polynomial function is of even multiplicity, the graph of f does what to the x-axis at x equal a when it's even? No, what does it do? It touches but doesn't cross, exactly. And when it's an odd multiplicity, the graph of f crosses the x-axis at x equal a. Very good. Number 6, the factor x minus a to the kth power, okay, when k is greater than 1, yields a blank blank x equal a of blank k. Okay. Lots of blanks in there. This is number 6. If you got your books open, a factor x minus a raised to the kth power, as long as k is greater than 1, yields a blank blank x equal a of blank k. We were just talking about it in number 5. Nope. All I'm talking about polynomial. There's a word shows up twice in number 5. That's the third blank. Multiplicity k. That's it. Okay, now we need the first 2 blanks. And the jar in this here. If I can see in this bright light. Okay. A factor x minus a raised to the kth power, as long as k is greater than 1, yields a blank blank x equal a. What is that called? K is greater than 1. Any ideas? Multiple root, a repeated root. Remember, x minus a to the kth power, however many that k is, that's how many roots you have there. Multiple root or multiple factor. Okay. Number 7. A polynomial function is written in blank form when its terms are written in descending orders of exponents from left to right. When it's descending orders of the exponents left to right, what do we call that form? Oh, we use it all the time. Used to be a gas company. Never mind, y'all wouldn't remember that. Earth to class, come in please. Never mind. Okay. What kind of form? You want the page number? No. Okay. It's top of page 130. Standard form. Excellent. Wow. Okay. Feel like a dentist. Okay, now, number 8. The blank blank theorem states that if f is a polynomial function such that f of a is not equal to f of b, okay, and then in the interval between a and b on the x-axis, f takes on every value between f of a and f of b. Intermediate value theorem. Excellent. All right. Those are over with. Okay. 2.3. We're still dealing with polynomial or rational functions. And remember what we've done so far is describe the graphs. Okay? But all along the way we said one of the most important things we can do is find these zeros. Now the graphs, we looked at end behavior because polynomial functions go to infinity. The further out you go, the further up or down they go. So we know the end behavior. Okay? That's what the leading coefficient test or leading term test tells us. Okay? Then we started factoring, and those tell us our zeros, but sometimes factoring alone won't give it to us. So now we're going to look at polynomial functions and synthetic division. Now, y'all probably had synthetic division, right? Okay? We'll be reviewing that, but we'll first start with long division. We'll use long division to divide polynomials by other polynomials. Okay? Then we'll use synthetic division to divide certain polynomials. Synthetic division will not work on some polynomials, but on others it will. So the ones that have, when you're dividing a polynomial by x minus k. Now that could be a plus there too. We'll deal with that. But if you've got that form, you can use synthetic division. If you had x squared minus k, won't work. If you had 2x minus k, that won't work. It has to be coefficient of 1, exponent of 1 for the variable. Okay. And then we'll use the remainder theorem and the factor theorem to come up with other features of the polynomial functions. So let's start with long division of polynomials. Okay? Before we do, let's review long division of numbers. And you tell me if you remember how this works. So let's do, I'm going to pick a number, not randomly, but I'm going to pick it. 12. Go into long division now, without a calculator. 619164. I didn't just make up the number, but it's a pretty good size number. How would you do that long division? Does anyone remember? Surely you do. And remember, long division, adding, subtracting, and multiplying, you usually start at the right and work your way left. Division, you start at the left and work your way right. So what would you do first?
How many times will we go into that number?
Into which number? To start with. The whole number? No, 61. You start at the left. How many times will 12 go into 61? 5 times. Then what do you do? Multiply. Okay, you divide first, then multiply. That gives you what? 60. Then you do what? Subtract. So divide, multiply, subtract. What would that give you? 1. And what do you do next? Bring down the 9. Now you see if you can divide again. Will 12 go into 19? How many times? 1 time. Then you what? Multiply. That gives you. And then you. And that gives you. And then you do what? Bring down the 1. And then you do. Yeah, you divide again. 12 will go into 71. 5 times again. Then you do what? Multiply. That gives you 60. Then you subtract. And that gives you 11. Now, every time you subtract here, you really ought to go back and check. When you subtract here and got a 1, that's less than 12. Keep going. Okay? When you subtract here, you got a 7. That's less than 12. Keep going. Down here, you got 11. Just barely less than 12. What if this were equal or greater than 12? What would you do? You go back and put a bigger number up there, right? Because, okay, so you got the idea. So after you subtract, you got 11. What do you do next? Bring down the 6. Then you divide, and that gives you, help me, maybe 9. Okay. Multiply, and what you get? 108. Excellent. And then you do what? And what you get? 8, and that's less than 12. So you Bring down the 4. That goes 7 times, and that gives you 84, and that gives you a 0. Man, it came out even. Now, what does that mean? When you got a 0 remainder, that means 12 is a factor of that number, and that thing is a factor of this number, because 12 times that gives you exactly 619,164. Exactly. Okay? If you had a remainder here, then 12 doesn't go into that exact number of times, so it's not a factor. Okay? Remember that? All right. Long division of numbers. Now let's consider long division of polynomials. Suppose you're given the graph of this thing. Now, just looking at that, it looks pretty clear that we may have a 0 right there. It looks like it crosses right at 2, 0. Okay? It would be easy to check, plug in a 2 here, relatively easy, and see if that comes out being 0. If it does, that's the exact. Over here, it's sort of hard to tell. Is that 1 0 or 2 zeros? It's kind of hard to see, isn't it? Okay? So how could you do this? If you think or suppose or guess that x equals 2 is a 0 for that polynomial function, how could you check to see what those others are? They're obviously not whole numbers. They may not even be rational numbers, but they could be. We just can't tell. It's certainly not a 0 or 1, so it's not a whole number. That one looks like it's a 2. Well, if x equal 2 is a 0 of this polynomial, then what is x minus 2? Hint, the questions we just did. A what? A factor, exactly. So x, because x equal 2 looks like it's a 0, then you know that x minus 2 would be a factor of f of x. So if it's a factor, that means we should be able to divide. I think I'll go back to the previous one. Okay. X minus 2 into 6x cubed plus 19x squared plus 16x plus 4. I don't think that's right. Let me go back and see. No, minus plus minus. Okay. I have a good memory. It's just short. Okay. That's the minus plus and a minus. Okay. We should be able to divide those polynomials. Wouldn't you think? If x minus 2 is a factor, we should be able to divide. Agreed or not? How do you divide polynomials? Just like we divided numbers. We start at the left and work our way right. So we begin with x. Will that go into 6x cubed? How many times? What's the coefficient here of this x? 1. 1 will go into 6. How many times? 6. Okay. And x will go into x cubed. How many times? X squared times. Do you see? So you divide first, then what was the next step? Multiply. 6x squared times x would be 6x cubed. And 6x squared times a minus 2 would be, a little louder, 6x squared times negative 2. Negative 12x squared. See how you write your numbers beneath the others. Now what would you do next? Subtract. Okay. Now with polynomials, you could have sign numbers. You do have sign numbers. And how do you subtract sign numbers? I find it easier to do it this way. Change signs and add. Really? Remember? It makes it so much easier than trying to subtract sign numbers. Change signs and add. So change that to a minus and that to a plus, and now add them. What happens here? It goes away. Just like the 6's went away. Just like the 1's went away. Just like the 1's went away here. The 8's went away there. they go away, okay? What do you have for the next term? You're adding now negative 7x squared, and what would you do next? Oh, and by the way, if this degree, now we're not talking about numbers, if this degree is greater than that degree, keep going. And it is. This has degree 2, that has degree 1, so keep going, keep trucking. So what do we do next? Bring down the plus 16x, okay? So we've divided, multiplied, subtracted, which is change signs and add. Now what do we do again? Divide. And x will go into minus 7x squared how many times? Negative 7x times. Perfect. Now what do you do? Multiply. Negative 7x times x is negative 7x times x, negative 7x squared, and negative 7x times a negative 2 is a plus 14x. Okay, and what do we do next? Subtract, okay, which is change signs and add. So we'll change that to a plus and change this one to a minus, okay? And when you add those, that one, whoa, that messed up, didn't it? My pen didn't come back. That's a 7x squared, a 7x squared. Those go away. And when you add those, what do you get? 2x, and then you do what? Bring down a negative 4. And then what do you do? Okay, again you look. Is this degree less than or equal to that degree? No, it's equal to. So we want it to be less than. Sorry about it. Is it less than? No, it's equal to. Keep trucking. Okay? So what do we do next? Yeah, divide. X into 2x will go how many times? Plus 2 times. And then you do what? Multiply, and that gives you 2x minus 4, and that comes out exactly even. So sure enough, x minus 2 was a 0 for that polynomial, okay? Which means that quotient up there is also a factor of that polynomial. Now what kind of a polynomial is this one? This is a cubic polynomial we really can't do much with. We could have tried factoring by grouping. That won't work. You know? But this is what kind of polynomial? A quadratic. Okay? Now, what can we do with quadratic polynomials? We got two options. Say again? We can either use the quadratic formula or we could try factoring. Which do you want to try? Let's try factoring first to see if we can come up with the other two factors, because if we can come up to the other two factors, we also have the zeros, right? The zeros and the factors relate to each other. X equal 2 is a 0, x minus 2 is a factor. Well, let's see what we can do with this one. 6x squared minus 7x plus 2. Will that factor? We don't know, but let's give it a shot. What is one possible factorization for 6x squared? There's several. A little louder. 3x and 2x. Let's try that one first. 3x and 2x. Okay, where do we turn next? The sign of the last term, and what is it? Plus, which tells you these two signs have to be, say again, both the same, and since the middle one's minus, they have to be minus. And what's the only factorization for 2? 2 times 1. Let's put them in that order and see if that works. No guarantee, but let's see if it does. What's that? That's the 7, yeah. It's pretty ugly, but it's a 7. Making fun of my writing, I can tell. Okay, yeah. I'll remember that. Okay, now. 3x times 2x. 6x squared, that works. 3x times minus 1. minus 3x minus 4x would be minus 7x and plus 2. Minus 7 minus 2 plus. Sure enough, those are the other two factors. Well, if those are the other two factors, what would be the zeros? Say that louder. Okay, 3x minus 2 equals 0, or 2x minus 1 equals 0. What does the first one give you? Add 2 to both sides, and that gives you 3x is equal to 2. Yes, 2/3. Divide by 3. So x equal 2/3, or this one would be, add 1 to both sides, and that gives you 2x is equal to 1. And what do you say? Whoops, I crossed out the wrong one. X equal 1/2. Divide both sides by 2. Sure enough, there are our two other zeros. X equal 2/3 and x equal 1/2. Let's go back to our graph and see if that makes sense. 2/3 would be somewhere to the right of this, and 1/2 right in the middle. Yeah, that looks like it makes sense. We do have two other zeros. They're very close to each other, but they're not the same. Okay? So you see, if we can figure out 1 0, then we can use division to try to figure out more zeros. So that's where long division of polynomials come into play. Okay? Now, I think example 1 is going to be the one we just did. Yes, divide 6x cubed minus 19x squared plus 16x plus minus 4 by x minus 2 and use the result to, that's exactly what we did. This is a review of it. X minus 2, which was a factor because we guessed that x equal 2 was a 0, so that makes that a factor. Divide that into there and see if it does go a whole number of times. And sure enough, we know it will. And how do we do this? Now, I don't like the way they do it, but if you like it, that's perfectly fine. I like to put this over this because that makes more sense to me. X will go into 6x cubed, but they put it over the same value here, which is fine. There's nothing wrong with it, but it just, to me, makes more sense to put it there. Either place you put it, doesn't matter. You divide first. X will go into 6x cubed, 6x squared times, then you multiply. 6x squared times x is 6x cubed. 6x squared times minus 2 is minus 12x squared. Then you subtract, which I like to do by changing signs, minus, plus, and adding. Those go to 0, and this will give you minus 7x squared. Bring down the 16x. Divide again. X will go into minus 17x squared, minus 7x squared, minus 7x times. That's where the minus 7x comes from. Multiply. Minus 7x times x is minus 7x squared. Minus 7x times negative 2 would be a plus 14x. And then you either subtract or change signs and add. I like changing signs and add. Change that to a plus, that to a minus. This goes away, and this is going to be a plus 2x. This degree is the same as that. Keep trucking. Bring down your minus 4. X will go into 2x 2 times, positive 2 times. 2 times x is 2x. 2 times minus 2 is minus 4. When you change signs and add or subtract, either one, you get a 0. That means this was a factor, and this also is a factor. Now, once you get it down to the quadratic, you can either factor again or use the quadratic formula. Okay? So they say, let's factor again. And sure enough, they get the same factor we did. We knew this was a factor because we picked it off the graph, and we saw that it worked. And then we found that was a factor. Factor that again, 2x minus 1, 3x minus 2, exactly like you found. That means that your 3 zeros are going to be x equal 2, which we've guessed to begin with. Okay? And, well, they don't say anymore. X equal 1/2 and x equals 2/3. They just sort of leave it hanging there. Now, what if you had done the long division of this into that, and you wound up, well, you did get a remainder of 0. However, what if you wound up with a non-zero remainder? That would have meant x minus 2 is not a factor, x equal 2 is not a 0, and it won't go in a whole number of times. So, sometimes that will happen. This time, we found it to be true. Now, here's another one. If you divide x squared plus 3x plus 5 by x plus 1, what will that give us? What do you do first? X will go into x squared how many times? X times. Then you do what? Multiply. X times x is x squared. X times 1 is x. Then you do what? Subtract. These go away, and this gives you 2x. Okay? Then x plus 1 will go into 2x. How many times? Oh, bring down the 5. X will go into 2x plus 2 times. Then you multiply. 2 times x is 2x. 2 times 1 is 2. But then when you subtract, you get a remainder not 0, 3. So x plus 1 is not a factor of x squared plus 3x plus 5. You have a remainder. All right. Now I'm going to jump ahead here. I'll kind of apologize for it, but not really, okay? I'm going to show you something. What would happen if you plug a minus 1, because if x plus 1 is not a factor, so that represents the value x equal minus 1, right? Okay. So what if you put a minus 1 in here? What do you get? Plus 1. You put a minus 1 in here. Say it. -3. Plus 1 minus 3 is -2. Plus 5 is plus 3. Look at your remainder. Whoa, okay. We're going to come back and see this is indeed true, but that's something else. It's rather bizarre that is true. That's coming up later in the section with the remainder theorem. But I just wanted to point it out to you now. Okay, in fractional form, what we just did there was take x squared plus 3x plus 5, divide it by x plus 1. This is the dividend. That's your divisor. This was your quotient, your x plus 2. Then you had the remainder, and you put the remainder over to the divisor, and that gives you your answer. So, this is how you divide. When they don't go evenly, you get a polynomial plus a rational expression. Some number. And the key here, this thing has to be lower degree than the divisor. Remember, if not, we kept on dividing. This has degree 0, that has degree 1. So that's how you write your answer. Or, you can write it this way. Multiply everything on both sides by x plus 1. Well, that would write this out, give you x squared plus 3x plus 5 is equal to this thing times that, x plus 1 times x plus 2. And when you multiply this by your divisor, this goes out, you get a plus 3. That's how you used to check division, remember? Multiply your quotient by your divisor and add your remainder. Same thing here. Okay? Now, this illustrates the following theorem, which we're calling the division algorithm. Okay? When you divide two polynomials, if they go evenly, the remainder is 0, you get a factor. If they don't go evenly and you get a remainder, then it's the dividend divided by the divisor is equal to a quotient, which is going to be a polynomial, plus whatever your remainder is over your divisor. Or rewrite that as your dividend is equal to your divisor times the quotient plus the remainder, just like you used to do in long division. So here's your division algorithm. If f of x and d of x are both polynomial functions. Okay? What does it mean to be a polynomial function? The key is the exponents. What's true about exponents in a polynomial function? They're whole numbers. No fractions, no decimals, no negatives. Okay? That's the exponents. Doesn't say anything about the coefficients, only the exponents. No negatives, no fractions, no decimals for the exponents. Whole numbers. 1, 2, 3, 4, 5. Okay? So if alpha of x and d of x are both polynomials, such that d of x is not equal to 0 because you can't divide by 0, right? And the degree of the d of x is less than or equal to the degree of f of x, then there exists a unique polynomial q of x and r of x, such that the q of x is your quotient and the r of x is the remainder. So in other words, alpha of x is some product of d of x times q of x plus r of x left over. Or you could have written this as alpha of x divided by d of x is equal to q of x plus r of x divided by d of x. Either one works. Okay? Now, if that r of x, that remainder, is equal to 0, then the degree of r of x, if r of x is equal to 0, or the degree of r of x is less than d of x, okay, the degree of d of x, then the remainder r of x, no, misread that again, where r of x is either 0 or less than the degree of d of x, period. Then, if the remainder is 0, then d of x divides f of x exactly by q of x, evenly into q of x. Those make factors. If r of x is not 0, they're not factors, but if r of x is 0, then these are factors of f of x. Okay, division algorithm. And as I said, you can also write that alpha of x divided by d of x, dividend divided by divisor, is equal to quotient plus the remainder over the divisor. Okay. In the division algorithm, the rational expression alpha of x over d of x, that's this one, is improper. What does it mean to be improper? You don't raise your pinky when you're drinking tea? No, that's not what it means. What does it mean? That means the degree of alpha of x is greater than the degree of d of x. Greater than or equal to. Because the degree of alpha of x is greater than or equal to d of x. Degree of d of x. On the other hand, in this thing, the remainder rational expression, r of x over d of x, it must be proper. In other words, the degree of r of x must be less than the degree of d of x. Can't even be equal to. This is improper, that's proper. Quotient is just a polynomial. Okay? Does that kind of make sense? Okay. Before you apply the division algorithm, be sure you do these two things. Be sure you write the dividend and the divisor in descending order of the variable. What do we call that? If they're written in descending powers of the variable, what kind of form is that called? Standard form. Okay, somebody remember something. Okay, good. Now, here's the other thing you have to do. Write it in standard form. If you happen to miss a power, like you have a 7x squared plus 3, you're missing your x term. If that's the case, you insert a placeholder with 0 coefficients for the missing power of the variable. Be sure you do that, otherwise you're going to get it all screwed up and you won't be able to figure out how to get it to work. Okay? So be sure you do those. Be sure you do dividend and your divisor in descending powers of the variable, and put placeholders with 0 coefficients in either division, dividend, or divisor where you're missing a variable. Okay. A lot of blah, blah, blah. Okay. They're skipping examples 2 and 3, so let's do those. Let's divide x cubed minus 1 by x minus 1. Okay? Now, when I say it that way, what goes where? Second. X minus 1 goes outside the house. And what goes inside the house? Okay, not quite. What are we missing here? We're missing some powers, aren't we? So what do? Zero coefficients. So what's going to be the next term? Plus 0x squared. Next. Say again. Not yet. You got a 3, a 2, missing a 1. Plus 0x. Now put in the minus 1. That's what we mean by inserting placeholders. Does everybody see that? Now, if you had an x squared minus 1 here, then it's a good idea to do x squared plus 0x minus 1. So you do it over here too. It's crucial you do it there. It's convenient to do it here, but it's absolutely crucial to do it there. Okay, let's do our division. What would you do first? X will go into x cubed how many times? X squared times. Now what? Multiply. And what does that give you? X cubed minus x squared. See how important it is to have that placeholder. Now what do? Subtract, which is the same as change signs and adding. So change that to a minus, that to a plus, and add. What does your first one give? 0. Next one gives you an x squared, and you do what? Bring down a plus 0x. I know it's not much, but bring it down. Now what? Divide. X squared, x will go into x squared plus x times. Then you multiply, and that gives you x squared minus x. Is that what you said? Okay. And then what do? Subtract, which is change signs and add. So make that a minus and that a plus. And what does that give you? X minus 1. And guess what that gives you? X will go into x plus 1 time. And 1 times x is x. 1 times minus 1 is minus 1. You get a 0 remainder. What does that tell you? Those are factors. There's a 0 remainder, so it is a factor. Okay? In other words, you could have factored this. But guess what, team? You already knew how to factor the difference of 2 perfect cubes, didn't you? What was that? Do you remember it? If you're factoring the difference of 2 perfect cubes, you have a little factor and a big factor. The first one is x minus 1. Cube root of this, same sign, cube root of that. Okay? Remember the next rule? Forget about the top. Take the first one here, x, square it. X squared. Then opposite the product of these two. Product of those two would be minus x. Opposite of that would be a plus x. And then square the last term, plus 1. Sure enough, that's what you get. It did factor it. We just showed it did. So guess what? You never have to remember that. The algorithm, you might say, for factoring sum or difference of 2 perfect cubes, just do your division. And you'll see what it works out. Just have to remember, divide by the cube root of the first, same sign, cube root of the second. You got it. All right. That was example 2. And they got it right too. Good for them. And how do you check that? You multiply. They showed you that. You can do it if you want. There is a checkpoint there. Not a bad idea to do the checkpoints. I would say as soon as you can get around to doing it. All right. All right, to erase this? Yay or nay? Okay. Let's do the next one. Divide negative 5x squared minus 2 plus 3x plus 2x fourth plus 4x cubed by 2x minus 3 plus x squared. How would you do that? After what? Okay, what goes where though? Decide that first. Yeah, the second one goes on the outside, so let's put that there and rearrange it in what kind of form? Standard form, so what would that be? X squared plus 2x minus 3. That goes outside the house. What goes inside the house? 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2. Have you got every term accounted for? Yeah. 2, 1, 0. 4, 3, 2, 1, 0. Blast off. Yeah, we got them covered. Okay. What do we do next? You set it up. How do we divide it? Here are 2 weekly there. 2 x squared. Perfect. Now what? Multiply, and that gives you 2x to the fourth plus 4x to the third minus 6x squared. Everybody see that? Now what? Change signs and subtract and add or subtract, either one. Minus, plus, and this next one will be a minus 2. I have to erase it, so hold on. That makes a minus. Okay. Now, if you don't like doing that, subtract, but be careful when you're subtracting. Okay? What does this give you? A 0. What does that give you? A 0. And what does that give you? An x squared. Bring down a plus 3x. And since you got 3 terms, go on and bring down the minus 2, too. Since you wiped out 2, bring down 2. Okay? Now what? Do what? Yeah, x squared will go in x squared plus 1 times. And what would that give you? X squared plus 2x minus 3. And now what do you do? Change signs and add. That would be a minus, plus, and that will be a minus here. Okay? And when you add, what do you get? Second? X plus 1. Right? That is lower degree than this, so there's your remainder. So there's 2 ways you can write your answer. Okay? Actually, you could leave it just like that. That's correct. If you wanted to write it according to the division algorithm, you could either say, I don't want to write all this, but I will. Okay, 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 is equal to x squared plus 2x minus 3 times your quotient 2x squared plus 1 plus your remainder x plus 1. That's one way to write it. The dividend is equal to the product of the quotient times the divisor plus the remainder. Or you could have written it this way. I don't want to write this again, but I will. 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 divided by that divisor, which was x squared plus 2x minus 3, is equal to your quotient, 2x squared plus 1, plus your remainder, x plus 1, over your divisor, x squared plus 2x minus 3. Either one of those is a perfectly good way to write it. frankly, I like that form test right there. It says it all. This is going into that many times with this remainder. Okay? But write it out the way they do on the back of the book. That's what it produces. Does that make sense? All right. So that was example 3. All right. Those were examples of long division. In this case, you had no other choice. To divide those two things, you've got to use long division. However, there are certain circumstances under which you can use synthetic division. And let's talk about that first. There is a nice shortcut for long division of polynomials as long as the divisors have this form, x minus k. Now that's really simple form. Here's what my rule is when I'm saying this. Your coefficient has to be 1 and your exponent has to be 1. If this was a 2x minus k, you can't use synthetic division. If that was x squared minus k, you can't use synthetic division. It has to be a naked x plus or minus some number. Okay? And that shortcut is called synthetic division. The pattern for synthetic division of a cubic polynomial is summarized below. And then we'll go into others. I sort of hate this. They just throw this at you. But here's the pattern. Okay. Let's start with the divisor. X minus k. Remember, the coefficient has to be 1, the exponent 1, before it'll ever work. Whatever this is, write this as if it's x equal. What would that equal? Rather x minus, if you put x equal, what would that equal? K, right? So it's always the opposite of this. If that's x minus k, it's going to be k. If that was x plus k, it's a minus k. You put that outside the house, okay? The opposite of this. If you had x equal, that's what goes out there. Now, what goes inside the house are just the coefficients. Because if you think about it, let's go back here. What happened to our x fourths? They went away. The x cubes, they went away. The x squared, they went away. The x's, well, they didn't completely go away. But anyway, you see you lose the x's, you're just dealing with coefficients. So that's the first simple thing you do. Number 1, outside the house, forget the x, just do the opposite of what's there. Okay? What's inside the house, just put the coefficients. A, B, C, and D. But guess what you better do first? Have this in the standard form. Exactly. Descending order of your power. If you put those coefficients when they're jumbled, you're going to get a jumbled answer and it's not going to be right. Okay, so you put the coefficients here and the number here, whatever that, the opposite of k was. Okay? Now, they never say this, but I say it. Skip a line, draw a line. Okay? Skip a line, draw a line. Bring down that first coefficient. Just the coefficient. Okay? Then you multiply k times a, and that gives you ka. Okay? Now, remember what we did back here? We changed signs and added, right? What we're doing now is changing the sign to begin with, so all you do is add. Remember that minus k? We changed the sign at the very beginning, so now all you do is a. B plus ka. And then you do k times b plus ka, you write it there. Add, multiply, add. Whatever you wind up with here, there's your remainder. Okay? So this is a lot of blah, blah, blah without really putting anything to it. You add the terms in the columns, you multiply the diagonals. Okay? By k. Okay. That algorithm for synthetic division works only for divisors of this form. Coefficient of 1, exponent of 1. And then what you put outside the house is the opposite of k, whatever that was. If that was x plus k, you put a minus k outside. If you put x minus k, you put a plus k on the outside. What you put inside? The coefficients, exactly. Okay. So let's do one. This is example 4. I think no, that's right. Okay. So you tell me what to put where. You put a -3 on the outside, and I like to block it like that. They block it differently. What do you put inside? 1. Say again? Zero. Why? You're missing the cubic term. Remember, you have to account for every term, right? You're missing the cubic term, you have to put a 0. Now what? -10. -2. 4. Okay, now what? My little rule? Skip a line, draw a line. Okay? Now what? Bring down the 1. Now what? And what you get? -3. And then add, you get -3. Then you multiply, you get +9. Then you add, you get -1. Then you multiply, you get a +3. Then you add, you get a 1. Then you multiply, you get a -3. Then you add, you get a 1. Okay? That's your remainder. I like to sort of do it like that. That's your remainder. Now, what you reckon these other numbers are here? What did we write in up here? The coefficients. So these are coefficients too, but you've reduced the power by 1. So this would be a quotient of x cubed minus 3x squared minus x plus 1 with a remainder 1. So you could write this plus 1 over x plus 3. Your divisor, right? There's your quotient, there's your remainder, there's your dividend, there's your quotient. There you have it. Okay? Uh-oh. Sounds like bad news. Okay. Must be running out of time. Let me give you a few homework exercises first. We've made decent progress on this. Do number 7. Do number 9. Do any of the odds 11 through 25. And then start doing some of the odds 27 through 35 anyway. Okay? And we'll pick up the rest of those next time. Good deal. Yeah, it's good to have you back.
I'm not contagious, but I have walking pneumonia.
Oh, yeah.
So, and this is my second time this year.
Yeah.
My doctor, he's had it 12 times this year.
Stay away from him. Yeah.
He's the one that's like, I already know what you got when you come in. We're just going to go ahead and do it. Last time they had to do a chest x-ray. And he's like, I already know what you got. Then this time they did blood tests, and before he even did the blood test, he's like, I already know it, but make sure.
I think I probably had something similar to that last year. It seemed like I had it all winter long. And I still have congestion from it now, so it's just nuts.
But first time it was in my chest, and walking pneumonia is one of the weirdest things that you can never get, because it behaves so weird, so stupidly. But now I have the opposite of what I had then, and I've just been housebound. I could not leave my house.
Right.
Finally was able to get out and go and get medicine and stuff with him. So.
Right. Did you finish your test? I can't remember.
I didn't, but I'm really busy. Right
Yeah, I understand.
I will get it done.
Yeah. I was just wondering. I didn't think I'd put your grade. I've graded what you've done so far, but I thought you wanted to come back. So whenever you can do it, get back to me. Okay.
I'll try, but like I said, I'm just kind of running over it.
Right.
I will get it done, I promise.
Right. Oh, I understand. I believe you. Okay. And but when we do finish this section, which probably will be on Thursday, we will. I'll have a quiz for you too. So.
Okay. Yeah, I'll get watching videos and stuff.
Right.
Make sure I got it all down. But thanks about understanding about
Oh,
going back to this test.
I've been there, done that.
because some teachers are just like, well, I'm sorry.
Yeah, well,
Yeah. Thank you about that.
yeah,
But
no
I will
problem.
definitely get it.
Yeah, well, I know you're a good student. You're going to do it. So, no sweat. Hope you feel better.
Thank you.
Continue taking care of yourself.